All right, finishing up the whole learning objective. There's a whole lot to this, but if you're practicing, you'll do just fine. So this is page 4 and 5. So we've been messing around with these functions, exponential functions, but I never gave you much formality. So now we're going to kind of define it a little better. So the population of Columbus, Ohio in 2014 is estimated to be 835,957. I actually looked this up. And growing at a rate of 1.2% each year. It's a percent increase. So f of x is my number of people, population. Right? That's my output. My input is the number of years since 2014. My A is my starting value. And B is my growth rate. So I had a 1.2% increase. So that means I start with 1 and I add 1.2%. Remember, as a percent, we move the decimal 2 places, so I'm moving it this way. So I'm adding 1 plus 0.012, right? That's the same as 1.2%. Okay, so what I get for my function is I take my original population in 2014. So I take 835,957 times my growth rate, B, which is 1.012, and that is raised to my x, my input, because I don't know how many years. And if we want to use this model to predict the population in 2030, well, I need to know how many years since 2014. So I'll subtract. Well, that means it's been 16 years since this. You can say f of 16 equals 835,957 times 1.012 to the 16th power. Okay, and I can actually use my calculator to find all of that for me. So there you see I have it typed in exactly the way I wrote it. I hit enter, and I get it in scientific notation. The population grew. This is it. And I'm going to round it to this. So now we're at 1,011,747 people. There's my answer. Now, I'm not going to try and give you ones that are that crazy like that, but you need to be able to use your calculator. So on number 2 is a little easier. Marissa invests $300 into a bank account that offers 5% interest and is every year. Write a function that models Marissa's bank account. So f of x is my money. X is my input. That's each year it accumulates interest. So this is years in the bank account. A is my starting value, which is 300. B is my growth decay rate. Well, again, I'm getting interest, so my money is growing. So I'm going to do 1 plus that 5%. Well, 5% is 0.05. So my growth rate, B, is 1.05. So my function is 300 times 1.05 to the x power. Matt bought a new car that cost $25,000. The car depreciates. Well, this means that the car is losing value. So approximately 15%. Okay, so this is not going to be a growth rate. This is going to be a decay rate because the car is losing value, not gaining. So f of x is my car value. X is the number of years. A is my starting value, while the value of the car starts at $25,000 and it's decaying. So remember, I start with my 1 plus or minus the rate. Well, in this case, since it's decaying, I'm going to say minus my 15%. Okay, so 1 minus 15% is 0.85. So my function is 25,000 times 0.85 to the x power. That's it. And I want you to try this one on your own. Okay, fill this in the box and see what you can get. All right.